Hello guys, Prathvik this side. So today we'll be solving a LeetCode problem container with most water. First, let's understand this problem more. We have given an integer array height of length n. There are n vertical lines drawn so that the two endpoints of ith line are I comma 0 and I comma height I. We have to find the two lines that together with the x-axis form a container so that the container contains the most water. We have to determine the maximum amount of water a container can store, and we cannot slant the container. So what this problem is basically saying is that we must find maximum amount of water that an area can store in our heights array. So let's first understand this problem more with an example here. Our height is this, and above this is our visual representation of our height array. As you can see, this part is containing the most amount of water here, and our area for this is 7 in height and 7 in width, which is 49 here, and we have to find our maximum area here. So our brute force approach can be here to check every possible iteration for this, every possible permutation and combination for this to find the maximum area, but that will cause a time complexity of on square and may cause many limited exceeded errors. So we will go with a refined and more optimized approach, which will be our two-pointer approach. Because in our two-pointer approach, we will calculate the area by first taking the two pointers at both the ends, which will give us the maximum width to get the maximum area. And then we will just shorten the width to find a taller height and calculate the maximum area for it. So let's go with that approach and let's start doing it by creating our two pointers here and two is equal to 0 and our int high is equal to height dot size minus 1. And now I'm going to create my max water variable, which will store our maximum amount of water or maximum area. And then we'll start iterating low, high. And now I'm going to first create my width variable, which will store our width of it, which is minus low, high minus low. This will give us the width of our container here. And then I'm going to create our height variable, current height, let's say current height that will give us our current height for it and low and why I'm writing min here is because the water might spill from the water will not spill from the highest height, but it might spill from the lowest height, so we are going to check for the lowest height and get the smallest pillar for this, and then I will mm, calculate the area for this current height multiply by our width to get the area width to get the width. Then I'm going to compare here which contains more water, our max water variable or our area. So to get comparison, we will use our inbuilt method of max here. And after this, I will write if low is greater or equal to our high. And if it is, we will simply just increase this or else we'll just decrease this. Now, why I'm writing this if condition is when we are starting from the both ends, our width is maximum. But after some iterations, our width might get our width will decrease, and the area will also decrease. And to increase the area, we must find a greater height to contain the most water, and this will find our greater height because this might be small. But if we move a little forward, this is great, and this is greater than this, and this will store more water, and that's for that, and that's why we wrote the if condition. And now we will return our max water, which contains our maximum amount of water stored, and let's see if it is working or not for test cases. As you guys can see, it is passing all the test cases, so let's submit our code and see if it is working. Our brute force approach would give us a time complexity of O n square for this one, but our two-pointer approach has given us a time complexity of O n because we are iterating through one only through our array for once, and our space complexity is O1 since we haven't used any data type for this problem. And that's it for my side, guys. Thank you guys for watching.